Okay, we are going to be taking some notes on section 4.3, just worrying about the other different angles and arcs that we find in circles. So if you've got your packet notes, you can go ahead and get those out. If you don't, you can print them off the blank templates, or you can just copy some of these examples down in your notebook. Okay, so let me go ahead and share with you my screen. Nope, wrong thing. Okay, all right, so this really is the same rule as an inscribed angle. The only thing that is slightly different is the fact that it is a tangent instead of two chords that are forming this angle. So when you are looking at this, notice the main thing is the vertex is on the circle, and whenever the vertex is on the circle, it's going to follow that same rule of an inscribed angle. So the angle itself is going to be half the measure of the arc that is formed. So look where this angle is. And since this is tangent at this point, that angle is going to be half of this arc right here, ABC. And then also that for when the vertex is on the circle, the 2 times the angle is going to be equal to the arc itself. All right, so let's go ahead and look at some of these examples. We have in this first one, we're looking for the measure of angle 1, which notice they gave us the arc that is formed by angle 1. So if we're looking at this one, it would be the measure of angle 1 is equal to the arc divided by 2. And so this case, it's going to be angle 1 is going to be 220 degrees divided by 2. So that means once we do that math, angle 1 is going to have a measurement of 110 degrees. Okay. In the second example, they gave us the angle. Notice that they're giving us this angle, and we're looking for the arc EFG. So I'm going to go ahead and highlight that, EFG. And notice again, in this particular example, the angle is forming the arc that we are looking for. So in this case, I'm going to use 2 times the angle equals the arc, right? Because the angle is half the measure of the arc, I've just basically rewritten this formula. So 2 times my angle. So in this case, 2 times 135 degrees is going to equal the arc EFG. Okay, and so when we do that, that's just going to be 270 degrees is the measure of EFG. Okay, in example 3, where this is just a little bit different. Notice they gave us this angle right here, 129, which helps me find this arc, because that's the angle that it opens up to, or I'm sorry, that's the arc that it opens up to. But we are looking for that arc right there. So a couple ways of doing this. There's really 2 ways. I know that in step 1, right, I can find this arc, HGF. So we know that 2 times 129 degrees equals HGF. Okay, and so 2 times 129, that's 258 degrees. Okay, but that's not what we're looking for. What we are looking for is HF, and notice that HF, I'm just going to put this, I guess, over here, step 2. HF is going to be forming the full circle with HGF. So we know HGF, that major arc plus the minor arc HF equals 360 degrees. So I can find HF by subtracting off 258 from 360. Okay, so this is a 2-step problem. And when we do that, let's see, that's going to be 102. There is another way, if you look at this, we can notice that this is a straight line. It's a tangent line. This angle HF, I don't know, whatever this other point would be, this is supplementary to this one. So I could essentially find, okay, well, this is going to be 51 degrees over here, and 2 times 51 would be 102. So there's really kind of two paths that you could go down, and we'll still get the same answer. In example 4, in this particular case, we are looking for the measure of angle 1. Notice that they gave us this major arc right here, 234 degrees, and that will help us find this angle, and we can subtract that from 180. Or I could find this arc by subtracting 234 from 360 and then take half of it. Either one is going to give us that same answer. So I'm going to go ahead and just find this angle first, and I'm just going to call this theta right here, and we know that theta would equal 234 degrees divided by 2, which in that case is 117 degrees. And then angle 1 plus theta equals 180 degrees. So angle 1 is going to be 180 degrees minus 117 degrees. And let's see, that's going to be 163. Okay. All right, so you can see that there's just kind of some multi-steps. So sometimes they are straightforward and you're just dividing by 2 or multiplying by 2. And sometimes we might have to either subtract from 360 and then divide, or subtract from 180 and then multiply. Either way, we are going to be looking at this like it's a puzzle. All right. Our next theorem is going to be when we have 2 intersecting chords and they form an angle, but they are not at the center. Okay, so the vertex is inside, but not at the center. So inside the circle, not at center. Okay, because if it were in the center, it would be a central angle. And here's what we can do. We know that vertical angles are congruent, but clearly this arc AD and BC are not going to be congruent to one another. And that's because it's not at the center. So the angles are going to be equal, but the arcs formed are not going to be equal. And the relationship that we have is that we basically take the average of these 2 arcs. We add the 2 arcs together and divide by 2. Okay, and so that's going to help us. We just always have to set this up, and we might have to do a little bit of algebra depending on what we are looking for. Okay, so let's see in this first example. Okay, we're looking for angle X, and notice that the arcs that are formed by those intersecting chords are 85 degrees and 57 degrees. Okay, and so when we are looking for this, we can say that angle X is going to be the average. So when I'm looking at this, it's going to be arc AC plus arc BD divided by 2. Okay, X degrees. All right, and so when I substitute in my values here, I get AC was 85 degrees, BD was 57 degrees. I want to add those 2 together before I divide by 2. And once I do that, this is 142 degrees over 2. So X is going to have a measure of 71 degrees. Okay. Now, since I know 71 degrees, I could find Y and say X plus Y are 180, which would probably be the fastest method in doing this right now, since we already know X. And if I did that, I'd get 180 minus 71, which is, let's see, 109. Okay. Now, if I didn't, like if they just said to find Y, I could still find x first. That is a possibility. The other thing would be that we know that all the way around the circle is 360 degrees. So the other way of looking at this would be arc AC plus AD plus BD plus BC equals 360 degrees. And so then when I substitute in, and the reason why I'm doing this is so that I can find arc BC so that I could use this formula to find y. Because notice y would open up to AD and BC. All right, so when I do that, I get 360 minus 85 minus 70 minus 57, and that is 148 degrees. So if I know this is 148 degrees, I can take the average of those and say y, that angle is going to be 70 degrees plus 148 degrees divided by 2, which when I do that, this is 218, and that's going to be 109 degrees. So notice either way, we could have found x first and then subtracted from 180 and get 109, or we could find this missing arc and then use the theorem where we can take the average of the two intersecting arcs, right, of the vertical angles. And so that's just, there's more than one way to get to some of these problems. I encourage you to just kind of trial by error and look and see whatever information they give you, what can you find? Okay, so looking on the back here, her last two examples, if we're looking for angle 1, we can see that, okay, we have the two angles the two arcs that are intersecting from the vertical angles. And in this case, we're looking for an arc. So I like this one because this is what we're looking for right here. And I have that arc right there. All right, so let's take a look at these examples. This one's pretty easy. We just know that I'm going to take the average of those two arcs. So 120 degrees plus 98 degrees divided by 2. And that's going to be 218 degrees, which means that angle 1 is going to be 109 degrees, just like our last example. All right, and then the next thing that we're going to look at is this one. So this one is not as straightforward. I know that, I'm just going to put a theta right here. I know that theta, whatever that angle is going to be the arc that I'm looking for plus 41 degrees divided by 2. Okay, I need to know what theta is, and I can find this because we know that it's a linear pair, and so theta itself is going to have to be 47 degrees. Okay, so I subtracted 133 from 180. I got 47 degrees. So that's 47 degrees, and that vertical angle is 47 degrees. Now I can substitute in 47 degrees here. And for some reason, these seem to be the most difficult for students because they're just not sure what to do with this fraction. I'm just trying to undo the division. So I'm going to multiply both sides by 2. Put this in. Okay, when I multiply this side by 2, those 2's are going to simplify to just being 1. And when whatever I do to one side, I have to do to the other side. So then I end up with, let's put 98, but this would be 94. Okay, and so when I have 94, and then I'm going to subtract the 41 from both sides, and I end up with x being a measurement of 53 degrees. Okay, so that's probably a good stopping point for right now, and we can want to do some practice of this. So right now we're looking at just vertex inside the circle, but not at the center, as well as just a continuation of vertex of our angle on the circle. Okay, so it's somewhere on the circle. So it follows the same rules as an inscribed angle. And that's it for now. Ask questions if you have them. Do some practice to figure out where you get a little bit confused. That's it.